Okay, so here we're still giving introduction, and this introduction is so important because from now till the end of the Rambam, everything is going to evolve around the concept of solving spherical triangles. So it's not really important you should know the formulas, because if you're not into mathematics, then you're not going to appreciate it, but you should get the concept that everything here is basically solving one of the 6 angles. We explained. There's every time you take, if you want to do it for yourself, you just take an apple or orange and take 3 rubber bands. One make in the center, that's the equator. Then make another rubber band. But all these things have to be great circles. It means they should be the full circumference. And then these 3 rubber bands are going to form something that's called a spherical triangle. For example, let's use this. This is from the old stuff we did already. This shows how the moon, this is the plane of the ecliptic. Here's the world. This is the plane of the ecliptic, means the Galvan Mazalas. And this is the moon's orbit. We showed that already before. The moon goes each month, half of the month he goes with an inclination of 5 degrees. Half of the month he's above the ecliptic, the second half is below. That's called, the Rambam explains that, called Roichat Tzpoini. And here, this area is Roichat B'Droimi, and it can go up to -5 or +5. That was the Roish with the Zanav, with this Maslow. Maslow means how much degrees he is traveled away from the node, from the Roish. So the Rambam gives us he gives us if you know the Maslow, means how much the moon is away from the node, from the Roish. It's called Maslow Rocha. According to that, we find out this angle, the angle that is it's called here small a. Why is it called small a? Because it's opposite big. The way the mathematicians have a very convenient way, you give the 3 points a big letter. Like this point is called big A, big B, big C. And then the opposite side are called small. That's the convenient. If you understand math, you'll see that there's a reason why the opposite, that's how it works. The opposite of big A is called small a. The opposite of big B is called small b. The opposite of big C, this area here, is called small c. So, to get you a picture what's happening here, what are the knowns and what are the unknowns? So, let's assume that the Maslul Harochav, that is calculated through finding out where the Yarech Amiti is, and subtracting from that the Makam Arosh. That's what we had in the previous Shurim. That's called Maslul Harochav, how much he traveled far away from the Kudus Arosh. That's here, this is the small b. You see, the moon went, this is how much degrees he is away. He obviously went this way, but in the average way, when we say the moon is up to there, it means in this plane of the ecliptic. Really, he's traveling here, but the calculations, when we say the moon is at a certain degree, we are assuming we're using this imaginary moon that travels on the ecliptic itself. It's not true, it goes above. So Masla Rochav means this imaginary moon, this average moon, that is on the plane of the ecliptic. It's not 5 degrees above, it's just on the ecliptic. And we take that, as Rambam explained, we take that number, we subtract from that the Makam Harosh, and that's called the Masla Harochav. How much is the moon away from the node? So what we know in this triangle, we know the side B. B is Masla Harochav. We know big A. Big A is 5 degrees. Yes, that's the Tia inclination. We also know, although it's not so obvious in the picture, we know the big C. Why do we know big C? Because really we draw a line from big B to big C, and that line is a line that hits the ecliptic in a 90-degree angle. Because when we say the roichav, what means the roichav? Roichav means we take from the pole of the ecliptic, we take all the way, we draw it till the plane of the ecliptic. If you don't understand that, then you should use a ball. So the rule is that anything that goes from the pole till the plane, till the center, hits it in a 90-degree angle. So basically, this BC is an extension from a line that's drawn from the pole of the ecliptic. It passes through the moon's orbit and it hits the plane of the ecliptic, and the place where it hits it on C, it's on a 90-degree angle. So C is 90 degree. You can try it with you can buy the 99-cent globe to understand better, but that's how it is. This line, this BC, is hits the plane of the ecliptic with a 90-degree angle. So C. So let's review again what we know. The three known things. Big C is 90. Big A is 5 degrees. Small b is the maslul harochav. So we have three knowns. What are we interested to find out? Small a. The opposite of big A. That is what we're looking for. Is called roichav. Roichav hayarech. So here, I explained, we use a certain formula. We gave you previously a whole list of formulas in the previous lecture. So I took out one of the formulas. You always have to know which formula to use. That's, with a little discretion, you can figure out. You don't need to be too bright for that. You just pick the one that sounds sense. So use the formula, this one. We're interested to know small b. So we try to we're interested to find small a. That's small a. So you see this formula has cotangent a. So we'll have to, use some math to isolate this thing, and then we can solve for cotangent a. So we use this formula, rearrange it, cotangent a times sine b. This is just by, if you know some math, you know how to, the equation, how to bring one part to the other part, the other side. Now, all the things that are known, we just plug in. So we know that sine b, for example, that's actually small b is maslul harochav. So we plug it in. Now, cosine b times cosine c, so cosine c is 90. So cosine of 90 is 0. So this whole thing gets 0. Now cotangent a sine c is 1. The sine of 90 is 1. Cotangent a is 5. So final version of this equation gets short. It's cosine maslul harochav again, cotangent rochav, that's cotangent a, times sine maslul harochav is equal to cosine maslul harochav. Maslul harochav, that's b, cotangent small b, cosine 90 plus cotangent 5 sine 90. Or cotangent rochav, flip this to the other side, is cotangent 5 times sine maslul harochav. You see, because this is cosine 90 is 0, so you just have cotangent 5 sine 90. That's 1. So you take this, so cotangent 5, cotangent, here, you take this cotangent A, that's cotangent rochav, times sine yes, okay. So the proper formula is here like this. You take cotangent rochav as cotangent 5 divided by, I don't take rho times, divided by sine mastal harochav. That is how you figure out the final solution for this problem. So we just showed here an example, a nice example, how the Rambam used spherical trigonometry. That's what he did. He used the spherical. They knew the Rambam, the Kadmonim knew the. They knew the spherical trigonometry formulas to find out the solution of this triangle. And that's how they got the mastal harochav. Now, this, I'll just start the next year, just introduction to this. So this is it's called, it's very good, you should just find out what a celestial sphere is in general. You just can Google it. Celestial sphere is, take a model that they sell in the stores. It's very good. You should get it. It shows the, here's the world in the center. You have the Galgal Mazalas, called the ecliptic, the signs of the ecliptic, celestial equator. This picture is made in such a way that the Galgal Mazalas is the center and the celestial equator is tilted. Doesn't really matter, because this is more to show it has a reason, but this doesn't matter. It's just a matter of how to show it on the picture. We all know that the celestial equator is 23.5 degrees tilted from the Galgal Mazalas. These are from here it's fall, the sun goes here, it gets winter, it's beneath the celestial equator, in this area it's summer. Here it's Kufas Tammuz, and as you go here, this is Kufas Tishrei, Kufas Tevis, and here it's Kufas Nisan. You see here Physis, that's Dogim, Mazal other Dogim. Okay, we'll try to just show you one more picture to get an idea of. Oh, this is this end of it. Okay, so basically, we understand that every time, this is introduction for the next year, you can have a celestial sphere, you can have 3 circles. What is the circles? One circle is the Galgal Mazalas, great circle. Second circle is the celestial equator. The third circle is called the horizon. So, horizon means you take this whole celestial sphere and you put a certain ring, that ring shows what part is visible for a certain location. And obviously that keeps on changing every hour. And that we will show in the next video, Be'ez Hashem. So remember, we have 3 great circles: celestial equator,